to compare alternatives using net present value, which is today class, and the next classes, which is IRR, internal rate of return, or benefit cost analysis, BC. We have to make sure that the two alternatives or more have to have the same number of years to compare. So problem one that we just did in the previous lesson video, two machine A and B have a number of years is 5, so both are 5 years, same number of years, good to go. What if you have two machines or two alternatives have different years? How can I do that? That is the purpose for this lesson video, and we apply that in problem 2. So compare NPV comparison of different life alternative, and like I say, have to be applied the same concept, same number of years for other methods that we talking about in the next lessons. So there are two approaches can satisfy the eco service life the same years. The first one, approach number one, compare alternative over a period equal to the least common multiple, that is LCM, least common multiple LCM for their life. Approach number two, we compare alternative using a study period of n years, also known as planning horizon. Planning horizon. So those are the two approaches. The question becomes, so which approach I go? So first, review calculus. What is least common multiple? For example, they project that have 2 years, either project have 3 years life, then the least common multiple is 6 years. Remember common factor? So that's what we have. If the project have 4 years life, the other 8 years life, then the least common multiple is not 16 years, but it's only 8 years. Make sense? So that is least common multiple. And then the question becomes, if I have a project that lasts, first alternative lasts 9 years, the other alternative it lasts 11 years. So what is the least common multiple of 9 and 11? It should be 99 years. 99 years. So we have to compare over a period 99 years. Do you believe that? For me, I cannot live another 99 years to see the benefit of that investment. So people don't want that. Too long. So that go to approach number two. I need to set a planning horizon. I will retire in 30 years, for example. Then I just want to do the investment something 30 years or less to see the benefit. So that is approach number two. Compare alternative using a study period length of n years, also known as planning horizon. So I plan for 30 years. Let's compare in 30 years. So which approach I'm going to use for this class? If the problem don't say anything about the planning horizon, don't specifically or explicitly say that is the years we compare, then automatically use approach number one, least common multiple. If they specifically specify the planning horizon, how many years, then approach number two. So let's apply that in problem two here. And you have another video that I show you how to draw the cash flow diagram for this scenario A and how to calculate for one example. So in this case, I just summarize the solution, and if you not get the detail understand from this video, go to the other video that I just briefly explained for machine A for the whole process for A, and then you can apply the same for machine B, and you're good to go. So problem two, a plant superintendent is trying to decide between two excavating machines with the estimate presented below. Initial costs 11,000 for machine A, 18,000 for machine B. Annual operating cost 3,500 for A, 2,500 for B. Salvage values, basically the amount to resell at the end of the useful life, 1,000 for A, mean that at year 6. B, 2,000 at year 9. A, determine which one should be selected on the basis of NPV, comparison using MAR of 12% per year. What is MAR? Minimum attractive rate of return. refer to the first lesson video. Which machine should be selected over a 9 years horizon if the service value of machine B is estimated to be 5,000 after 8 years? So which method I use for A? Which method I use for B? B, they specify 6 years horizon, so that specifically say how many years you use approach number 2. A, which one should be selected? They don't say any about the planning horizon, automatically apply approach number 1. So least common multiple. So that's what we have in here. By the way, if you are not clear what I'm explaining A here, to find out draw the cash flow, you can go to another video where I explain why this cash flow come from and how to find out the NPV. Make sense? So let's do it here briefly, and then you can look at the other video for that. So approach 1 for A, least common multiple of 6 and 9 years, it will be 18 years. And then we draw the machine A cash flow, and we always draw the cash flow diagram for each alternative. In this case, machine A, you have spending 11,000, so 11,000 at initial cost, and operating cost 3,500 every year, 3,500 for 6 years. At the end of year 6, I resell for service value 1,000. Realize going up 1,000 here. And now you see 18 years, but my machine only lasts 6 years. What should I do? I assume that same machine I can buy at year 6, at the end of year 6, and have the same operating cost for the next 6 years, which is from year 7 to year 12. And then at the end of year 12, I have the same service value 1,000. So with that, I can, what does that mean? I resell at the first machine A for 1,000 at the end of year 6. I buy the new machine for 11,000, same operating cost for the next 6 years. At the end of year 12, I sell the second machine A for 1,000, and then because we need 18 years, I buy again the third machine A, 11,000, operating cost from year 13 to year 18, 3,500 per year. At the end of year 18, I resell for 1,000, and I stop. I don't buy the third machine because that only compare for 18 years. So with no 11,000 going down at year 18 in here. Everyone see that? No 18,000. Keep that in mind. No 11,000 going down at year 18, because that we stop the planning horizon and the least common multiple in 18 years. Similarly, for year 9, for machine B, we have 18,000 initial cost, 2,500 annual operating cost, 2,000 at the end of year 9. So that's why we have this cash flow. Machine B, 18,000 initial cost, 2,500 every year for the first 9 years. And then the machine's end of useful life, I get the service value 2,000. You can put in Craigslist to sell your old machine, 2,000. And then I have to buy a new one to operate for the next 18 years, which is from year 10 to year 18. So buy the second machine B, operating costs assume the same. At the end of year 18, I resell for the same amount, 2,000. And with that cash flow key point, then you can be able to find out the NPV for each. So NPV, print all the money, go down to the present value. That 11,000 already did times 0, so we can have that is negative 11,000 NPVA. And like I said, you look at another video when I explain to find out NPVA, and of course you can do that for NPVB. 3,500 for P over A, 12%, 18. What does that mean here for this cash flow? 3,500 for the first machine A from year 1 to year 6. 3,500 for second machine A from 7 to 12. 3,500 per year for the third machine A when I buy it at year 12 for year 13 to year 18. So it means that every year from year 1 to year 18, I spend 3,500 every year. Same amount annually, and I want to print that net present value time now 0. So given A, 5p. That's why we have it P over A 12%, 18. Make sense? And then we have this is at year 6. I receive 1,000 service value, but I have to spend to buy a second machine. A 11,000. That's why 11 spending negative, receive 1,000, and that is one single amount. So P over F 12% 6. That basically here negative 11 plus 12, so it will be 10,000. One single at year 6 bring to time 0, so that is P over F 12%, 6 years. That you have it. Similarly for this one, similarly for at year 12, so that's why we have 12% 6. P over F 12% 12, year 12. The last one, 1,000 amount at year 18, bring to time 0, given F 5P, P over F 12% times 18. And like I said, yes, I explained in another video detail, so you can get that. So where that number come from, you can go to the reference, exam 2 reference, look for the table of 12%, right? And that you can have here P over A 12%, 18, 7. You have that 7.2495, 7.2495. P over F 12% 6.566, 0.506, should be 0.506. And then 0.2567, 0.2567, 0.13 for P over F 12% 18, 0.13. So you have that one, you get 43,878.95 negative NPVA. Similarly, we have NPVB from that one. We have negative 18,000, negative 18,000, 2,500 from year 1 to year 9, and then year 10 to year 18. It means that we have annual amount every year from 1 to 18. That's why we have P over A 12% 18. Same factor put down here. And then at year 9, we have to spend 18,000 to buy the second machine A, machine B, and we receive the service value of the first machine in the first 9 years. At the end of year 9, 2,000. So you have that is 18 times 2, P over F 12% year 9, and 2,000 service value here. So you get there. And similar, use the table, you have 41,633. And compare this, you have to select the gray state NPV, NPVA equal to negative 43,800, NPVB negative 41,600, so that we have NPVA less than NPVB, so that you choose the gray state, choose machine B. So that is first scenarios. The second scenarios that you have planning horizon is 6 years. If the service value B is estimate 5,000 after 6 years. And like I say, I have another video to show you part B, but now I briefly show you. If you get it, then good. If not detailed enough for you, go to that video to explain in detail. So planning horizon is 6 years. Service value at B now is 5,000 at year 6. So we can draw the cash flow diagram for B. So machine A is 6 years, so it's only the first cycle. That should be okay with you. For B, we have 18,000, 2,500 for every year, 6 years. And the service value at year 6, because the useful life 9 years. When you sell at year 9, 2,000, but this one is 5,000. And that is approach number 2. And you just find out NPV for each of them. And of course, B over A 12% 6. And that you can go to the table P over A 12% 6, which is 4.114. So that's why you have 4.114. This one we have it before in part A, so you have 0.5066. you get negative 24,883. NPVB, do the same. 18,000 zero, I don't have to convert. 2,500, same amount for 6 years. So given A, 5P, so we have it P over A, 12% 6. Similarly, 5K at the end of year 6, one single amount at year 6, I want to print it 2 times 0. Some money in the future, bring to present value, P over F, 12% 6. So that same factor print down here, you get 25,745.50. And that is negative. So we compare, yes, NPVA greater than NPVB. So you choose machine A because NPVA greater. So as you can see, the planning horizon it play a good role in determine which machine we choose. In part A, we choose machine B. If we make a shorter horizon, if we compare for 18 years, now it's only 6 years, we choose machine A, not machine B. So as you can see, very important, the time that you compare the alternative, it may give you different outcome. So with that, we good, and go to the lesson. Next video, we learn a capitalized cost. And like I say, we have another 2 videos for these problems alone to explain to you how to draw cash flow diagram for part A and how to solve part B.